Hello students, this is lesson U3A03A. By the end of the lesson, you should be able to say, I can use ASA to prove triangle congruence and apply CPCTC to prove parts of triangles congruent. Within this lesson, we will be utilizing the following theorem, which is ASA. So ASA stands for angle, side, angle. And if you look at this, the diagram here, which describes ASA theorem, you will notice that we have AC is congruent to WY. You'll also recognize that we have angle A here is congruent to angle W, and then lastly we have angle C is congruent to angle Y. So hence, the way in which we read this, the side in this case is going to be the included side. So unlike the last theorem that we had talked about, which was side angle side, where the angle was the included angle, here we have ASA, where the side is the included side, which means the side is sandwiched in between the two given angles. Once we prove two triangles using ASA or SAS or SSS, right? We've covered up until this lesson, okay, two theorems, and with this new theorem, we now have three different ways of proving triangles congruent. All of the lessons, okay, follow the application of this theorem, which is that all corresponding parts of congruent triangles are indeed congruent. So, because of this, okay, the nature of this lesson will look and feel very similar to the past two lessons. Let's take a look at four different examples. So let's take a look at this guy right here. So this example here, you're given a diagram with two triangles, okay, and the givens are already pre-labeled on the diagram. So let's just pause the video for a moment and see if you can tackle this problem on your own. The goal is to prove the two sides they're congruent, as well as that pair of angles there. All right, so hopefully you got some time to analyze this on your own and that you did press pause. I'm just going to write down all the given information, which is that EF is congruent to MN. And we also recognize, based on the diagram, that angle E is congruent to angle N, and that angle F is congruent to angle M. These are the three given statements here. All right, so based on just this set of givens, I can now see, again, the order in which that these statements are written in does not have to be in the exact order as ASA. Just recognizing that the side in line 1, okay, that I listed out as being congruent, that side is in fact the included side based on the way in which the diagram is drawn. So in this case here, okay, we can then, as a safe conclusion in line 4, we can say that triangle EFG will in fact be congruent to triangle NML. And again, the order in which you are naming the triangle, the letters of the triangle, does matter greatly. Because again, from previous lessons, okay, it was emphasized that angle E corresponds with angle N, angle F corresponds with angle M, and then angle G corresponds with angle L. Okay, so the order in which we are listing out the letters matter greatly. So what exactly is the reason for line number 4? Well, according to the beginning of this lesson, this is actually true because of angle side angle. So once we've proven that the two triangles are indeed congruent, we are well on our way to figuring out why the various sides of the corresponding parts of the triangles should also be congruent. We can then simply list out that EG is congruent to NL, that FG is congruent to ML, and that angle G is congruent to angle L. And this is all because of, again, CPCTC. Corresponding parts of congruent triangles are congruent. Let's take a look at another example. All right, So in this case here, please pause the video again because the nature in which the problem is set up is very, very similar to the past lessons. So pause the video, see if you can see if you can tackle what this question is asking for and how you can prove those statements. Hopefully you did pause the video and that you did get a chance to tackle the problem. Let's list out all the given information here. So I know that XZ bisects angle X and angle Z. This is a given statement. And as we've seen before, where we've utilized like the midpoint formula or a bisector, or tackled problems involving line segments or points that bisect a given segment, okay, we are going to treat this in a very, very similar manner. So one thing I can say with absolute certainty is that I know immediately that angle WXZ must be the same as angle YXZ. And similarly, I know that angle WZX must be congruent to angle WZX. This must be true based upon the information that the given statement had presented. So we know that line XZ bisects angle X and angle Z. So therefore, those angles, as I've drawn there, must be the same. So therefore, I can say that angle WXZ will be congruent to angle YXZ. We also recognize in the same manner that WZX will be congruent to angle YZX. And this is all true because of, well, exactly what a bisector does, okay? This is the definition of angle bisectors. So I know that these two lines will be true based upon the same two sets of givens, based upon the same reason, which is the definition of what an angle bisector does. All right, so now that we recognize this, okay, we have two pairs of corresponding angles that are congruent, okay? So we have an angle and an angle, but we do not have yet a side. But if you take upon closer inspection, you should be able to recognize that side XZ is being shared between both triangles. And because side XZ is being shared between both triangles, that is the included side that we are looking for in proving that the two triangles are congruent based on ASA. So why is XZ congruent to XZ? Well, that's because of the reflexive property. Having this understanding now and having established all these things, we can then safely conclude on the fifth step that triangle WXZ will be congruent to triangle YXZ. And this is again because of angle-side angle theorem. So we're set out to prove why angle W is congruent to angle Y, and we're also set out to prove why XW is congruent to XY, and we're also set out to prove why ZW is congruent to ZY. Well, all of these are just corresponding parts of congruent triangles, aren't they? So we recognize that corresponding parts of congruent triangles must be congruent. So therefore, again, these three statements are true all for the same reason, that corresponding parts of congruent triangles are in fact congruent. Okay? Let's take a look at another example where we have, again, a very similar setup, okay? The given information here is that we have side WX is parallel to side YZ, we also have that WY is parallel to XZ. And this is true because, again, the information that's given to us. See if you can pause the video for a moment and figure out why those corresponding sides are in fact the same. So by now, hopefully you got the chance to take a look at this. And what we're going to try and do now is we're going to try to apply concepts that we had studied back when we were studying parallel lines cut by a transversal, which is actually the kind of situation that we have at the moment. If you look at WX, side WX, and then side YZ, it's cut by a transversal YX. So immediately upon inspection here, I already know what's going to happen. These two angles will end up being the same because those are alternate interior angles. Similarly, I can say the same thing, that YW and XZ, those two lines are also parallel. So therefore, I can say that these two angles here are going to be congruent to one another because of, again, alternate interior angles. And those two pairs of alternate interior angles do not need to be the same measure as the one stated earlier because there's no reason for them to have to be the same. All right. So now with this said, okay, we have a lot of information that we can put down now. What I'm going to do is I'm going to list out all the angles that was mentioned, which was angle WXY is congruent to angle ZYX, and then angle WYX will be congruent to angle ZXY. And why are these things true again? That's because we have alternate interior angles. And we know alternate interior angles are in fact congruent. And both statements are true for the same exact reason. So these are alternate interior angles and they are the same for both reasons. So now that I have both of those pairs of angles are the same, we do not yet have ASA yet. We need one other information, which is an included side. We now know that YX is going to be congruent to YX. And this is true because of the reflexive property. So because it's true with the reflexive property, I recognize now that I have the included side. YX is congruent to itself. So we now have enough information to say that triangle WXY is congruent to triangle ZYX. And this is true because of ASA. So now that I have all this information here and I've proven the two triangles congruent using ASA, I can now say, oh, that side length WX must be congruent to side length ZY. And we also know that WY must be congruent to ZX. All for the same reason that corresponding parts of congruent triangles must be congruent. So it's again CPCTC. All right, we're going to do one last problem. So in this case here, again, the notation here is slightly different. Here, notice that there's an arrowhead and then there's a tick mark there. So what this is saying is, I'm telling you that AB and DE, they're not only parallel, but they are congruent. So those two line segments are parallel and congruent at the same time. Pause the video, see if you can solve or prove why those statements are true. So by now, you've got the chance to think about this. Let's talk about this together. I know that AB is parallel to ED. And not only that, I know that AB is congruent to ED. And this is true because of the given statements here. Or actually, it wasn't explicitly stated, but it's drawn in. All right, so now that I know this, okay, notice that DCB is a transversal. And notice that ACE is also a transversal. So because of this, I know that these two angles are going to be the same because of alternate interior angles. I also recognize that these other two angles here are also going to be the same because of alternate interior angles. So let's go and list this out. So I know that angle BAC is going to be congruent to angle DEC. And I also recognize that angle ABC will be congruent to angle EDC. And the reason for this is we have, again, alternate interior angles are congruent. And both of these statements are true for the same exact reason, that we have alternate interior angles are congruent. Recognizing this now, we actually have an angle-side angle relationship set up. We have angle, side, angle. So therefore, on the fifth line, I know that triangle ABC will be congruent to triangle EDC. And because of this, I can say that this is true because of ASA. Alright, so because this is true because of ASA, I can then say that AC is congruent to EC, and that BC is congruent to DC. And this is true again because of corresponding parts of congruent triangles are congruent.